This is a video from section 1.2 in a linear algebra class. A matrix is in row echelon form, abbreviated REF, if it satisfies the following three conditions. Number one, if a row does not consist entirely of zeros, then the first non-zero number in each row is 1. We call this a leading one. Number two, if there are any rows that consist entirely of zeros, they are grouped together at the bottom of the matrix. Number three, in any two successive rows that do not consist entirely of zeros, the leading one in the lower row is to the right of the leading one of the previous row. The following matrices are in row echelon form. Let's take a look at Part A. Suppose I give you the following matrix. The first row is 1, 2, 0. The second row is 0, 1, 0. The third row is 0, 0, 0. So notice how this matrix is in row echelon form. The row of zeros occur at the bottom. If we look at the one in the first row, right, that's the first non-zero entry. If we look at the one in the second row, that is also the first non-zero entry. So the first non-zero entry in the first and second row are ones, leading ones. Now, look at the second row of this matrix and the first row of this matrix. The leading one in the second row is to the right of the leading one in the first row. So all the conditions have been met, and therefore this matrix is in row echelon form. Now, let's take a look at B. Suppose I'm given the following matrix. In the first row, we have 1, 2, 3, 4. In the second row, we have 0, 0, 1, 0. In the third row, we have 0, 0, 0, 0. The row of zeros occur at the bottom. And if you notice, right, the leading one in the second row, right, the first non-zero entry, is to the right of the leading one in the first row. Okay? So all the conditions have been met, and therefore this matrix is in row echelon form. Now, one question I have for you is, now this again is in row echelon form. If this entry in the third row is 1, right, this is a leading one. And that leading one in the third row is to the right of the leading one in the second row, and the leading one in the second row is to the right of the leading one in the first row. So it's still in row echelon form. Okay? Now, if that entry was, for example, 2 and not 1, it is no longer in row echelon form. So we have to be very careful. So I'll leave it as a 1 because we don't have to have a row of zeros necessarily. It's just if we do have a row of zeros, they must occur at the bottom. Okay. Now, let's take a look at C. Suppose I give you the following matrix. Suppose I have 1, 2, 4 in the first row, 0, 1, 0 in the second row, 0, 0, 1 in the third row, and 0, 0, 0 in the fourth row. Here's another matrix that is in row echelon form. The row of zeros occur at the bottom. If we look at the third row, we have a leading one, that's the first non-zero entry, and it's to the right of the leading one in the second row. And the leading one in the second row is to the right of the leading one in the first row. So it satisfies all the characteristics and is therefore in row echelon form. Okay, now, a matrix is in reduced row echelon form, abbreviated RREF, if it is in row echelon form and satisfies the following extra condition. Each column that contains a leading one has zeros everywhere else in that column. So again, a matrix is in reduced row echelon form if it is in row echelon form to begin with. And then the leading one can be the only non-zero entry of that column. Now, let's take a look at some examples there. So we'll call this again part A. Suppose I give you the following matrix. 1 0 0 0 0 1 0 0 0 0 1 0. Now, if you look at the leading one in the first column, it's the only non-zero entry. If you look at the leading one in the second column, that's the only non-zero entry. And if you look at the leading one in the third column, that's the only non-zero entry. And so this matrix is in reduced row echelon form. It is absolutely in row echelon form. So we just had to verify that that fourth condition held. So if we take a look at B, suppose I give you this one. The first row is 1 0 negative 3. The second row is 0 1 5. And the third row is 0 0 0. So this matrix is in row echelon form. Absolutely no question. If you look at the first column, the leading one is the only non-zero entry. And if you look at the second column, the leading one is the only non-zero entry for that column as well. And so that fourth condition held, and therefore this matrix is in reduced row echelon form. Part C. Suppose I give you the matrix 1 0 5 5 0 1 3 2. And here's another matrix in reduced row echelon form. Now, the following matrices are not in reduced row echelon form or row echelon form. And I want to give you a couple of examples there. Let's take a look at this one. Suppose I give you the matrix 1 2 4 5 for the first row. Now, first row looks fine, but let's take a look at the second row. I'm going to give you 0 2 3 4. So notice how the leading one in the second row is not a 1. The minute that that first non-zero entry is not a 1, you are not in row echelon form. And if you're not in row echelon form, you are absolutely not in reduced row echelon form. Let's take a look at B. What if I did this to you? So if I do 0 1 0 1 0 0 0 0 1 0 0 0, okay, it looks good, right? In the first row, the first non-zero entry is a 1. That's fine. In the second row, the first non-zero entry is a 1. In the third row, the first non-zero entry is a 1. what's the problem with this? If you look at the second row, the leading one in the second row is to the left of the leading one in the first row. And if we look back at our conditions, the leading one in the first row has to be to the left of the leading one in the second row, and the leading one in the second row has to be to the left of the leading one in the third row. And so neither one of these matrices are in row echelon or reduced row echelon form. Because remember, to be in reduced row echelon form, you have to be in row echelon form to begin with. And that's a good stopping point for this video. This is a video from section 1.2, and we looked at the definition of what it means for a matrix to be in row echelon form or reduced row echelon form. So, okay, thank you.